Welcome to our group's video on MetaMaterials. We will be giving a general overview as well as explaining the theory, uses, and reasons for use of metamaterials. Metamaterials are engineered structures with varying electromagnetic properties. Metamaterials are materials which have properties that impact electromagnetic waves. The wave that they focus on are light waves. What is special about metamaterials is that they are able to impact both the electric and magnetic components of light in comparison to most other natural materials, which can only impact the electric component of light. The way that metamaterials impact light is by bending the radiation of waves of visible light once it passes through the material's complex structure, which gives the effect that the light waves aren't there. Meta is a Greek word which means to go beyond, which is where the word came from.
So why are they used? Through the use of metamaterials, engineers are able to manipulate how electromagnetic waves, such as light, interact with different structures. By choosing specific types of matter and altering the orientation and arrangement of its unit cells, which are small internal structures, it is possible to construct various metamaterials with desirable electromagnetic properties. For instance, it is possible to create objects with unique electromagnetic properties that would not occur naturally. For this reason, metamaterials are highly useful and have many practical applications.
Metamaterials are composed of tiny unit cells made of either plastic or metal. In order to alter the properties of light, the spacing between the units are smaller than the length of a light wave. The electromagnetic properties of a metamaterial can be created or altered based on the design of the structure to suit certain needs.
There has been some research and a potential application with metamaterials and antennas. Antennas can be coated in metamaterials to enhance the radiation and matching properties of the waves. These special antennas can be used in something called electromagnetic energy harvesting. And the goal of this is basically to collect and recycle microwave energy. These antennas are much smaller and more efficient than regular antennas. Being able to recycle this energy would be incredibly efficient since waste energy is minimized. Another application of metamaterials is in MRIs. The way an MRI works is by immersing a person into a strong magnetic field which oscillates radio frequencies. Metamaterials can be used to create an artificial magnet out of non-magnetic materials. And with these artificial magnets, it's much easier to focus the magnetic field and result in a clearer image from the MRI.
Another application of metamaterials is in the military. By applying the theory of wave diffraction of electromagnetic waves, example light, to mechanical waves, sound, scientists and engineers were able to design and construct a unique acoustic metamaterial that can be used to modify the way sound waves interact with the body of a military submarine. This new metamaterial will have the ability to force sound waves that would normally reflect or bounce off of the submarine to bend around its body. As a result, sonar would not be able to receive the sound waves that reach the submarine. This implementation of metamaterials in the construction of submarines will allow them to remain hidden from enemy radar.
The use of metamaterials has led to the creation of the superlens. The superlens is a lens in a microscope that can allow scientists to see beyond the diffraction limit, which has not been done before. The superlens can reach a magnification of over 4 times that of traditional microscopes. And it can also be used to view live viruses, which could lead to scientific discovery. Thank you for listening to our presentation on metamaterials.